Alright, back with the next question. This is again from exercise 7G, question 9. So, find n given that the sum of the first n terms of this thing, 2k plus 3, equals 15, 17. Well, what would the first terms look like? If we just go with u1, we're going to have 2 times 1 plus 3 is going to be 5. u2, we're going to have 4 plus 3 is going to be 7. u3, 6 plus 3 is going to be 9. You can see pretty easily either from the formula or by doing a few quick values. A little quick check that this is just an arithmetic sequence, isn't it? u1 equals 5, d equals 2, which makes sense. We're adding on an extra 2 each time. We can find the sum of this sequence and let it equal 15, 17. So we know our rule, Sn equals n over 2, 2 times the first term plus n minus 1 times the difference. We could use first term and last term here, but of course we don't know what they are, so we have to go with this one. And then we say let Sn equal 15, 17, u1 equal 5, and d equal 2. What do we get? 15, 17 equals n over 2, 2 multiplied by 5 plus n minus 1 multiplied by 2. Looks a little bit ugly, but we're going to neaten it up pretty quickly. 15, 17, in fact, that's, oh no, we'll just do it now. We'll sort it out in a second. n over 2, what have I got in here? 10 plus 2n minus 2. So we're going to call that 2n plus 8. Look at that, there's a common factor of 2 in there. That's going to cancel with that one. Might as well do that first. So 15, 17 equals n. The 2's cancel and I'm left with n plus 4. Times 15, 17, 0 equals n squared plus 4n minus 15, 17. I am not, and this will come as a shock to you, not all over my multiples of numbers that include 15, 17. So let's go for a bit of old-fashioned calculator work, sketch it and find the answers, or what else could you do? You could use quadratic formula to get that. I think it'd be more fun to try and figure them out, but we'll go to the calculator because I've got lots to do and we don't have much time. So my preferred method is to sketch the graph, because that way I can see what's going on, make sure if I've made a mistake that it's pretty obvious. So x squared plus 4x minus 15, 17. And you see how easy it is to make a mistake there, 15, 17. Execute that, draw that. Can't see it at all, there's a surprise. If I set my viewing window to standard, am I any luckier? No. And of course you're not, because 10 squared is only 100. This is 1500. So let's change our viewing window. Let's just go from negative 30, or negative 50 to 50 should cover it. 50 squared, 2500, that'd be better. Negative 50 to 50. Put the markers in at 10, it doesn't really matter, does it? The y minimum. Well, I'm interested where they're equal to 0, so I could just leave it like that, but let's try and get a better view of it. So let's go for, I don't know, negative 2000 up to 2000. Maybe that'll look pretty, maybe it won't. We'll see. Have a guess. Doesn't really matter at this stage. So we exit and we look at the sketch. That looks beautiful, doesn't it? I don't know why. Oh, it's only gone to 0, obviously. When I did the 2000, it didn't hit equals correctly or something, but either way, we've got what we need now, don't we? G-solve, what are the roots? Negative 41 and 37. N equals negative 41 or 37. Well, that's fair enough. Find n given that n is a number bigger than 1. We reject the negative, and we've got 37 terms in that one. What about the next one? Same thing, except what is this? This is the sum of a geometric sequence. What are the key terms in our geometric sequence? If you can't see it just from the rule, just check it. I'm going to go with t again just because we've used u in the same video, but in an exam you could use a separate question. You can use u again if that's what you're used to doing. If I substitute in 1, I'm going to have 2 times 3 to the power of 0, which is 2 times 1, which is 2. What would my second term be? It would be 2 times 3, which is 6. My third term, I'm going to have 3 minus 1 is 2, so 2 by 9 is 18, and you can see here I've got T1 equals 2 and R is equal to 3. That's my ratio. Okay, sum of a geometric sequence, which is a geometric series. What is that? So the sum of the first n terms equals, in this case, T1, but otherwise U1. R is positive, so I'm going to go R to the n minus 1 over R take 1. And we're going to say, let T1 equal 2, R equal 3, turn that into a comma, and Sn equal 177146. What does that mean? 177146 is equal to 2, 3 to the n minus 1 divided by 3 minus 1 is 2. It's looking pretty nice, isn't it? This is going to be so simple. That's 2, which cancels with 2. There you go. I can add 1 to the other side. 177147 equals 3 to the power of n. You probably know your powers of 3 well enough to do that, but if you don't, what are we going to do? Take the log of each side, so the log of 177147 base 3, I could use the definition there, equals n, and then you could do that on your calculator or change a base rule, which I'll do because I don't know how to find those other buttons. So that's going to be the same as log 177147 divided by log of 3, and then I can use natural log or log base 10, doesn't really matter. By the way, it's actually going to be pretty easy. So log of 177147, I'm guessing, yes, there we are, divided by log of 3. And it's 11. There you go. What looked like a really hard question, probably looked harder than the other one. It's actually turned out to be pretty easy. That's question 9. I hope that helps you and you can follow what went on there. Look, reality, you're probably not going to get much of this summation notation, but just being able to find where a sum is equal to a number, that's an important skill that you could get given, so good that you practice that one anyway. Alright, see you in the next one, guys.